machine learning. And essentially, for this tutorial, we will only be focusing on implementation of what you have covered in class in code. For a lot of you, this should help you with your project and to some extent with your recent last graded homework. So before we get started, I just want to tell you कि आपके tutorial 9 का जो content है, it is available in this tutorial document. There are 5 versions of this notebook that are available for your information. With that, we're going to get started. If you have any questions in between, please feel free to turn your mic on and ask, otherwise, I might miss what you are saying. So, the first essential step is well, you're going to want to prepare your data before you work with it. And you have numerical features, and then you have features that are non numerical in nature. When we look at numerical features, there are two important concepts that we're going to cover. You have normalization, and then you have z-score normalization, essentially feature scaling. Feature scaling is an important step that you need to take prior to you passing your data to your ML model. I'm sure this has been covered in class as well. It is important for you to ensure that the features that you're working with are on the same scale. Otherwise, some features will end up dominating the rest in your model. Let me give you an example, which we're actually going to work through in this notebook as well. If you have two features, age and income, और age की जो range है, that could in your data set suppose that the minimum age is 21 and the maximum age is 83. So then age की जो आपके पास range है, that is 62 numbers, 62 only, 83 minus 21. However, suppose your salary, which is going to be a much bigger number, suppose that ranges from 95,000 to 500,000. Now you have a range of 400,000, 405,000. If you directly pass this data to your model, so what will happen is कि salary का feature जो है, it will dominate age, and we don't want that to happen. So normalization is done to bring all of the features to one scale before you pass it to your model. And essentially, in this case, आप इन्हें 0 to 1 की range में ले आते हैं. So, x bar is representing the normalized value of your data point. X is the initial value. You do this for each data point. So, you compute the distance of that value from the minimum and then you divide it by the range, which is the max minus min for that particular column. इससे आपका data 0 से 1 की range में आ जाता है your given column, and then the minimum value corresponds to the number 0 and the maximum value corresponds to the number 1. So the closer your number is to 1, the higher it was in the original data set as well. So let's look at a simple sample problem based off of what we have covered. Suppose कि ये आपके पास data frame है income and age का, and now we want to normalize it. We're going to normalize each column at a time. I'm not going to write the code from scratch, so I will walk you over this against the formula that we've done though, just using simple pandas commands. वैसे आपके पास इसके लिए built-in function भी available है. So I've computed the minimum age, the maximum age, and I've also obtained the minimum and maximum income. And then I create a new column, scaled age, which equals, well, age minus the minimum age divided by max minus min of age. And then I do the exact same thing for income. And this is what it comes out to be. Just one thing to observe over here is कि scaled age 0.00 जो है, that corresponds to the age of 25, which was the lowest age in your data set. Similarly, a scaled age of 1.0 corresponds to the age of 45, which was the maximum age available in this data set. And the same thing follows for income as well. Let's look at how you do this using your built-in scaler available in sklearn. We're going to look at stats models when we implement our models, and we're also going to look at sklearn. So for your project, we don't essentially restrict you. You can work with sklearn, you can work with stats models, and if you're comfortable doing so, तो आप TensorFlow and PyTorch के साथ भी work कर सकते हैं. PyTorch actually gives you a better grip over what you're doing, but we're only working with simple models in this course. So from sklearn.preprocessing, you're going to import the min-max scaler. So इस normalization को हम min-max scaling भी कहते हैं. That's another term. They're used interchangeably. And now this is the data set that we will be working with. A lot of you would remember this data set already because we have worked with it in our previous tutorials as well. So we can very easily pick the numerical columns and then we can scale them. In this case, we have picked the column of life expectancy, which is over here. Did I spell it wrong? Actually, there's a space ahead of it for some reason. Interesting. Oh, it's life expectancy data. So this is the series that we are working with. Anyway, I am obtaining the values and I'm displaying the values just to show you guys कि ये dot values आपके लिए क्या कर रहा है. You will use this later on as well. So essentially, it's just converting your data set, your series to an array, and then it's returning that array for you. And then you have to initialize your scalar. आप scalar को initialize करते हैं and scalar के आपके पास well, you have two features available. You have fit transform and then you have simple transform. We will look at the difference in just a bit when we move on to our first model. So for now, I'm calling fit transform. Scalar dot fit transform को मैंने एक important चीज pass की है and that is just my series of life expectancy. उस series की मैंने dot values करके pass की हैं and this reshape operation is not important for you right now. Anyway, this is what I can see now. My values are in a range of 0 till 1. And just for your information, अगर इसका हम access करके भी देख लें dot min, that's 0 and dot max is expected to be 1.0. With that, we're going to move on towards standardization. So, simple normalization जो हमने अभी cover किया है, it's also called min-max scaling, and standardization is also called z-score normalization, which you have also covered in class. But to reiterate, well, standardization के लिए आपके पास ये वाला formula है. The z-score of each given data point is equal to that data point minus the mean of that column divided by the standard deviation of that column. Min-max scaling transforms your column in such a way that then all the data points range from 0 till 1. However, z-score normalization will transform your dataset in such a way that it will now have a mean of 0 and a standard deviation of 1. Standardization is essentially more robust to outliers since it's relying on the mean and the standard deviation. Min-max normalization is not as robust to the outliers क्योंकि for instance जो हमने age वाली example देखी, suppose your ages were ranging from 25 till 80 and then due to some error कोई 1000 की age enter हो गई भी है. The problem with this is कि since हम divide करते हैं by the minimum, by the maximum minus the minimum by the range, so now the range will be so large that most of your values will just be clustered around 0.0 point 0 and you will hardly have a value of 2 जो anomalous values हो सकती थी around 1.0. This does not mean, and typically people do ask me, this does not mean कि आप यूज ही सिर्फ z score normalization करते हैं. Min max scaling is also used. For instance, in your neural networks, typically min max scaling is used. For instance, when you're working with images, the pixel values against, well, you have three color channels, red, green, blue, and against each color channel जो पिक्सल की वैल्यू है वो 0 से 255 के बीच में रेंज करती है. So we always bring these between 0 and 1. Since there couldn't be an error on your part over here, you're reading images automatically. So we know कि इसमें outliers का कोई issue नहीं है आपके पास. All right, let's look at the same sample problem. So I have the exact same data set and I'm going to do the exact same thing. I obtain the mean age, the standard deviation of age, and then I obtain those two for income as well. So DF normalized age equals DF age minus the mean age divided by the standard deviation for the age column that I've obtained. And then I do the same for income. And this is what I obtain. इसकी interpretation भी आपको पता होनी चाहिए. Uh, you have a certain value of 0 and then you have, well, if you obtain a value of 0, that just represents your mean value. Interestingly, ये data set distributed इस तरह था. Your mean value will correspond to a value of 0. This means that 35 was the mean age of my data set and 75,000 was the mean income of my data set. You should also know कि अब आपके पास पॉजिटिव वैल्यूज भी आ सकती हैं एंड आपके पास नेगेटिव वैल्यूज भी आ सकती हैं. Positive values just represent those data points that were greater than the mean, and negative z scores just represent those data points that were less than the mean. So I can see that 25 and 30 ki age ke against I had negative values, which just means that they were farther from the mean on the left side. And then I had positive values for 40 and 45. The higher this value is, the higher the original value is, the jitna aapka z score zyada aayega, the more distant it is from the mean age. And then the same thing follows for income. Again, we're going to use sklearn ka function, sklearn.preprocessing se, as opposed to the min-max scaler. Now you're importing the standard scaler. And standard scaler ke liye bhi you have all the same functions available. Again, I'm going to use dot value, so I've just displayed this over here. Again, I'm initializing my standard scaler, and then I call dot fit transform and I pass it my series. And this is what I obtain. Are there any questions up until this point? Okay, so we're going to move on to your linear regression. I want to show you guys using stats models first, and then I will show you the alternative implementation. Just may you're going to use the model that is available in sklearn. However, you will realize that sklearn library mein se we are using two important things. I have imported a function train test split, and then I have imported mean squared error and R2 score. All right, so I've created a data set. This is what my data set looks like. Actually, हम एक दफा complete data frame भी display कर लेते हैं. So you have 40 values available for the mid score, the final score, and then the overall aggregate of the student. The overall aggregate must obviously also include maybe their project score, their assignment scores, class participation, etc. But this is the data that is available to you. And the problem at hand is that we're going to try and predict their overall scores using their midterm scores and their final exam scores. Let's quickly look at the correlation matrix between these three variables. And we can see that सारी correlation की values 80% से ज़्यादा हैं. Actually, 88% is the minimum that you observe, which logically means that you should be able to predict well the overall score using these. So there are a couple of steps, a series of steps that you will follow in the process of training a model and then making your predictions and then well evaluating on your test set using those predictions. The first thing is कि you would want to do a 60-40 train test split. 60-40 is a number that I've chosen over here. आप इसको alternatively 30-70 भी कर सकते थे. This really depends on you. Typically, though, we try to make an 80-20 split for training and testing. And then from the 80% for training, we make a further 80-20 split for validation. But that's just a rule of hand. So I call this function जो मैंने ऊपर import किया था from sklearn.preprocessing train test split. Train test split को मैंने अपना data frame pass किया है as my first argument. Then I have passed the test size, the proportion of data that I want to keep in testing. 0.4 means ke take 40% of my rows at random and put them into my test set. The remaining 60% would go into my train set. So you can just as well change this very easily. Now 75% of your data will go into training. Random state is something you add, and I would encourage you to add in your projects as well because it helps you with reproducibility. We should be able to reproduce the results that you are reporting in your project. So anyway, what this does is कि ये मुझे दो data frames return कर देगा, train data and test data, by making this random split. And this is what I've obtained. For as long as I keep using the same random seed, I will obtain the same split for future use. जो इसने यहाँ पे प्रिंट किए हैं वो indexes हैं. All right, anyway, now that I have done that, I still need to prepare my training data and my testing data, though. One important part of preparation that we have looked at for numerical data is bringing your data to one scale. And just by looking at my initial data set, I think I can confidently say that midterm scores की values की range different है, final scores की values की range different है. See, typically I can see that they're more than midterm exam ke scores, and then overall key range is different. So ideally I would want to bring my essential features to the same scale. Anyway, SM is what I have imported my stats models as. So I'm using SM over here. So one important thing that you have to do is कि train data के अंदर you only select the features that you are using in order to, well, predict whatever it is that you're predicting. And right now, the features that I'm using are the midterm and final scores. And what I'm predicting is the overall score. So X train के अंदर आपके वो features जाते हैं जिन्हें आपने prediction के लिए use करना है from your training data. Y train में you have the variable, the target variable that you were trying to predict using the prior. So from your training data that will go into Y train. So मैंने ये तो select कर लिया है, but then I'm using a function from the stats models library, add constant, and essentially what this function does is कि stats models का जब आप ML model use करेंगे, तो by default it will not add an intercept. You add a constant yourself for intercept using this. And when we shift to our sklearn library, on the other hand, so then you don't have to explicitly do this. In ytrain, मैंने simply एक series pass कर दी है जिसमें I just have the values for the target variable from my training set. I've done the exact same thing for my test set as well. So this is part of my data preparation. इन्हें हम एक दफ़ा display भी करके देख लेते हैं. So this is what my constant looks like to show you. It has just modified my data set. So I'm going to perform simple linear regression using ordinary least squares right now. So SMF में आपके पास available है in your stats models library .ols. Formula आप define करते हैं in such a manner कि first you give the target variable and then you give the variables that you want to predict it using. So what I'm trying is I'm trying to predict the overall score just using the final score, and then you pass it the training data. Dot fit ka function will, well, this is how my model will fit to my training data, and this is why I only pass it my training data. and hence I have initialized my model. मैंने इसको इनिशियलाइज किया एंड इनिशियलाइज करते ही मैंने इसको फिट भी कर लिया है एक्चुअली. नेक्स्ट आई वुड वांट टू प्रिडिक्ट ऑन माय टेस्ट सेट. सो इस मॉडल का फंक्शन मैं कॉल करूंगी डॉट प्रिडिक्ट एंड आई विल जस्ट पास माय टेस्ट डेटा टू इट. And then when I display the summary for this model, so it will tell me, okay, well, it has given me all my coefficients, it has given me my error values, and it has given me a lot of things that we have not covered and are out of the scope of this course. But for instance, इसने आपको minimum R square दिया that it was able to achieve. Now, of course, I would want to evaluate it on my test data. And here I have already stored my predictions, Y predictions. So I will just use this. अब मेरे पास Y test है, which are my ground truths for my test set, and then I have Y predictions, which I've just obtained using my fitted model right now. And I will compute the MSE and I will compute the R squared. And this is what I have obtained. So here again, we're just using built-in functions that are available to us from the sklearn library. And in दोनों functions को आप पहले ground truths pass करते हैं and then you pass them your prediction. So this is what I have obtained. I'm going to attempt multiple linear regression now to help you quickly recall. Simple linear regression may you were predicting one variable using one variable. Multiple linear regression may you are predicting one variable using a combination of other variables. So essentially, I have the exact same piece of code, but my formula equals overall what I'm trying to predict, and then that as a function of mid plus final. So pehle I was actually only using final, and then everything else shall remain exactly the same. Now, when I do my evaluation, so I will obtain, well, in this case, मैंने ये MSE and R squared obtain किया है. One important thing to note is that increasing the number of variables is not necessarily always going to improve performance. This is a process where you will have to go back and forth, try different models, try different combinations of features that you are passing to your models. Sometimes your model will be too simple, and sometimes it will be too complex. You will not have enough features. So this is something that you'll definitely want to iterate over. Are there any questions up until this point? All right, so we're going to move further. And like I told you, we will cover the exact same thing using sklearn as well. Okay, I find that a lot of people are more comfortable with this library. So now I'm just using sklearn. And I'm working with the exact same data set. Oh, this is just for your information. I've displayed scatter plots. I can observe a moderate to strong positive correlations between the midterm score and the overall score, and of course between the final score and the overall score. In this case, it makes a lot of sense to us anyway. Sometimes ऐसा होगा कि आप एक feature का अपने target variable के साथ correlation observe नहीं करेंगे. But this does not mean that you do not add that feature to your model, because it's very likely possible that a certain combination of features does correlate with your target variable. So you don't do this to just to discard certain variables. All right. So we're going to model our data. We're going to follow the exact same series of steps. You're going to define the features and the target. Since हमने अब sklearn में use करना है, तो slightly आपका सिर्फ format change होगा, but your sequence of steps will more or less essentially remain the same. So I've selected the midterm and final marks to go into X. X means my features. And then Y ke andar I've only passed my overall score. So Y is your target variable. You will notice that I'm using dot values. This is why I've covered dot values before as well. मैं इसको वैल्यूज पास कर रही हूँ, यहाँ पे भी ये टपल्स क्रिएट कर देगा एंड उन टपल्स की ये array क्रिएट कर देगा because this is the expected format. I'm not passing it pandas की series या data frames altogether. So I can quickly just show you what X looks like as well. See, it's an array जिसके अंदर, well, let's not call them tuples. आपके पास arrays ही हैं that are representing your features. So step 2, you split the data into training and testing sets. I've used the exact same function, train test split. पहले इस function को मैंने एक data frame pass किया था और इसने मुझे split करके दो data frames return कर दिए थे, my train data frame and my test data frame. अब मैंने इसको x and y pass किया है, तो it will actually return to me four things: train x, train y, test x and test y. बाकी मैंने सारा कुछ उसमें as it is ही define किया. The test size, the proportion of data, of course, that's going into testing, and then my random seed. So to quickly show you what xtrain, for instance, looks like as well. See, exact same format, बस randomly उसने split कर दिया. Similarly, I can show you what ytrain looks like. Of course, ये corresponding values ही निकलती हैं. Now, step 3, one essential step which we did not do prior to this. You are going to scale your data based off of what we have just recently learned. I'm going to use z-score normalization in this case. So I've initialized my scalar and then मैंने train data के ऊपर function call किया है scalar dot fit transform, but then testing data के ऊपर मैंने simple scalar dot transform call किया है. Pretty sure that this is a part of one of your homeworks as well. Can someone tell me why? Interesting. I want you guys to think about this. Pretty sure this is a question somewhere. But I will tell you what, आप fit transform को सिर्फ अपने train data के ऊपर use करते हैं. टेस्ट डेटा के ऊपर अगर आप फिट ट्रांसफॉर्म यूज करें या आप कंबाइंड डेटा के ऊपर ट्रांसफॉर्म करके फिर उसमें से टेस्ट की प्रोपोर्शन निकालें, तो दैट essentially results in data leakage. We want to avoid data leakage. So which is why you use these two separate functions. This is a fairly common mistake actually as well. Anyway, once we have scaled our data, we can take a very quick look at our scale data as well. This is what I have been able to obtain. So इसने सारे features को independently scale कर दिया. Next, you are going to define your model. We are using multiple linear regression, so I've defined a linear regression model. In step 5, you are going to, oh, one important detail. हमने जब stats models में ये काम किया, तो you had to specify OLS. You don't have to do that when you're working with sklearn. This model uses OLS by default. So step 5, you're going to fit this defined model to your scaled data, and this is the function that I'm using for that, model.fit. Fit को मैंने सिर्फ दो चीजें पास की हैं, my scaled features and then my, well, ytrain, the target variable from my train set. So then I have step 6. I will make predictions on the test set, for which again you have a simple function model.predict. Predict को सिर्फ मैंने scaled testing के features pass किए हैं. It obviously does not need the ground truths. Like this one needed ytrain. इसको y test नहीं चाहिए. Y test is something that I only need in order to evaluate its predictions. So to take a quick look at what we have obtained over here. So ये भी आपके पास array format में predictions आ गई हैं. Given that I have my ground truths available, I can evaluate my model now. In order to evaluate my model, I'm again using these things जो मैंने sklearn.matrix से functions import किए थे. Mean squared error, and then I have R2 score. And this is what I've been able to obtain. Are there any questions up until this point? Okay, I'm going to pause over here for a minute on account of the azan, and then we'll continue towards our next regression model. All right. Logistic regression you have not covered in class yet, I believe. Like, you're going to go over this topic, inshallah, in Tuesday's session, in Tuesday's lecture. Regardless, I will not go into the details of logistic regression and how it works. Rather, I still want you to know how you implement it in code. Largely, this notebook focuses on how you're preparing your data in order to pass it to your model. Logistic regression is something that you are using for classification. अभी हमने regression use की to predict numbers, to predict values, like आपने overall score predict किया using the midterm score and the final score, which is well, it's a continuous number. Now you want to predict classes. For instance, you are given certain symptoms that a patient has been experiencing, and you want to predict one of the three different kinds of diseases that they could have. So, this would be an example of classification. Alternatively, you could be predicting whether they have a certain disease or not, which is also an example of classification. When you have binary classification, तो आप 0 1 predict कर रहे होते हैं, just corresponding to my disease or no disease example. In well, in multi-class classification, you have multiple classes available. So anyway, we're using sklearn for this. The model that you're using is logistic regression. You will cover the details of how this model works as well. I will definitely walk you over the matrix that you will be using shortly though. So I have an interesting data available. If I'm not wrong, I should have this data here as well. Yeah, no, my bad. You don't have this data set available here. We are just synthetically generating this data. मैंने कुछ genders define कर दिए, कुछ education levels, कुछ marital statuses की values, and then I generated 500 samples. So I have 500 rows available for my data set over here across 5 different columns, and I'm trying to model certain purchasing behaviors right now. All right, so you have age, gender, education, marital status, and purchased. You would want to model your data. I want to predict ye wali value, whether a person is likely to make a purchase or not. We don't care what the purchase is about right now. We want to predict whether an individual is likely to make a purchase given their age, gender, education, and marital status. मैंने इसको start इस तरह किया है कि I've defined step 1 as you defining your features and your target. But when you look at your data science life cycle holistically, you will see that this is not really your first step. The first step is you looking at your data, and then you go back and forth between exploratory data analysis and data cleaning. We're not going to do that right now. You have my generated data set available. However, कुछ चीजें देखनी important है. So let's look at um इसका हम plot बना लेते हैं. Kind equals box. And this is what I see. So my idea of making a box plot was just to see के age की values कितनी skewed थी, whether I had a lot of outliers available or not in this column or not. अगर मेरे पास age में outliers होते, तो perhaps I could confidently say that extreme values represent anomalous values. And then maybe when I'm scaling this column, I would just steer clear of min max scaling. Similarly, I would want to observe कि मेरे पास gender के लिए क्या available है. So वैल्यू काउंट्स का आप प्लॉट भी बना सकते हैं. Let's make a bar graph. All right, so I have three unique gender values available. You have male, female, and other. Then let me try and do the same for education. And this is what I have. Bachelor's, high school, master's, and PhD, with most of my values for bachelor's as the highest, well, I'm assuming highest level of education. Similarly, let's look at marital status. So इसमें भी you have three unique values: married, single, and divorced. Purchased के लिए, I don't think you need to particularly look at this, but hopefully you only have two unique values available. All right, you have two unique values available, and this is what you're trying to predict. You're doing binary classification. So we would want to prepare all of these features before defining a model and passing our data into the model. अभी हमें इसमें से सिर्फ age को prepare करना आता है, because that's a numerical value, that's a number, you can scale that. Anyway, first I will define my features and my target variable. Defining my features, उसके लिए मैं ये भी कर सकती थी कि x equals df, and then I could have selected, what do I have available here? Age, gender, education, and marital status. And this is what x looks like. What did I spell wrong? Oh, this is what I did wrong. So this is what x looks like. क्योंकि these are all the variables जिन्हें use करके मैंने purchased को predict करना है. Alternatively, I could have just dropped the purchase column and left the rest to x, in which case I obtain the exact same result, just to show you. So this is what I've done. And then when I'm selecting y, so of course I only want purchased over here, which is a pandas series right now. Anyway, then you have step two, and step two will be broken down into multiple steps for our problem now, because there are a lot of variables that you have to encode. So you're going to encode and you're going to scale, and I'm going to scroll down because, well, ideally ये हम सबसे पहले कर लेते हैं since we've already covered this. So for age, I'm using my standard scalar, and I'm using standard scalar ka fit transform function, and then I am scaling age. So this is what age looks like right now. Alternatively, in this example, आप अगर min max scaling use कर भी लेते तो it still would have been okay, because we have not seen a lot of outliers in our data set. Of course, one thing that you have to be careful about that has been missed in just this particular instance of the notebook is कि आपने scalar dot fit transform directly use कर लिया है. You should have done this after maybe splitting your data, and then you would have called simple transform on your test set since you're using the standard scalar. Anyway, I have scaled my age column. Now I want to understand what I can do with the rest of my columns. You have ordinal variables, you have nominal variables, and then you have binary variables. So हम इसको देख लेते हैं. आपके पास gender है, for instance, and as you've already seen, अगर मैं dot unique देखूं, तो these are the unique genders that are available to me. Of course, my model at the end of the day, whichever model it is that I'm using, it's expecting numbers. It's not expecting strings. So I have to find a numerical way to encode these. One way of going about this is कि मैं male के against 0 allot कर दूं, other के against 1 allot कर दूं, and female के against 2 allot कर दूं. But can someone tell me the problem with this encoding scheme? This is called ordinal encoding. So the problem is essentially कि जब आपके मॉडल को सिर्फ numbers चाहिए, so, if you have a female entry and then you have a male entry as opposed to it, and female को represent करने के लिए you've used the number 2, but male को represent करने के लिए you've used the number 1. So, essentially, this is what it will feel like. Female is somehow, it's a bigger value, it carries more weight than the value male, which is not true. These are certain categories, and we don't want to give more weight to one category than the other. So this encoding scheme does not work for us, not when you're encoding gender. I will tell you what works, but before that, let's look at education and see what we can make work in education. So education में this is what you have available, and I think कि आप इसको simply encode कर सकते हैं, because I know कि अगर मैं high school को 1 की value दे दूं, sorry, high school को मैं 0 की value दे दूं, bachelor's is equivalent to 1, master's is replaced by 2, and then PhD is replaced by 3, then I'm still passing meaningful data into my model, because this represents a certain order. My variable values are following a certain order. Hence, ordinal encoding works fine for me. I know कि bachelor is something that comes after high school. I know that master's is something that comes after bachelor's, and I know that PhD is something that comes after master's, which is why I can encode education in this manner. Now, what about marital status? इसको भी मैं इस तरह encode नहीं कर सकती. I can't write 0, 1 and 2 over here. I have to encode it in a different manner as well. So before we encode this particular column, let's encode what we have decided right now, what we've decided for education. Education को आप ordinal encode करेंगे, and this is how I've done so. I can use a simple dot apply operation for this. I could have just as well used a lambda function inside dot apply, but anyway, मैंने खुद define कर लिया. So education order, इसको एक value pass होती है. If the value is high school, I return 0. If it's bachelor's, I return 1. If it's master's, I return true, and else के अंदर you're only left with PhD, I return 3. And then I apply this to my education column essentially. And this is what I obtained. So this is what my data set looks like now. Moving on to the rest of our values which were important. So हम gender के पास वापस आ जाते हैं. This is what you have available. I'll tell you कि आप इसको कैसे import करेंगे. हम इन्हें ordinal way में नहीं import कर सकते. For such categories you perform, for such categorical variables you perform one hot encoding, which has been covered for that matter as well. So this is what I would do. 0, 0, 1, and then other के लिए I could have 0, 1, 0, and then female के लिए I could have 1, 0, 0. Now I have not given my model any information whatsoever about whether a certain unique value of gender is greater than or more significant than the other in any way. So essentially what will happen is कि जितनी unique values हैं ये उतने unique columns बना लेगा. I will have a column like this, df gender underscore male, and then I'll have another column that will look like this, underscore other, and then I will have a third column which will look like this, female. सो इसेंशियली जिस रो के अंदर जेंडर की वैल्यू मेल थी वहां पे ये वाली चीज 1 हो जाएगी और बाकी दोनों 0 रहेंगी. And essentially it will work the exact same way for every other unique value as well. So now it's kind of like each unique value is represented by 0 or 1. There is one important thing that we take care of when we're following this encoding scheme though, when you're doing one hot encoding, and I will show you. बट फर्स्ट हम इसका कोड देख लेते हैं. सो आपके पास pandas का ही एक फंक्शन अवेलेबल है, pd.getDummies, एंड देन इसको आप पास करते हैं योर whatever series it is of your data frame that you want to encode in a one hot fashion. Prefix is something that you don't necessarily have to pass to it. So essentially, if I was doing it for gender, for instance, तो मैंने उसको अगर प्रीफिक्स ना पास किया होता, तो सिंस द ओरिजिनल कॉलम नेम वाज जेंडर, तो नए कॉलम्स इन नेम्स के साथ क्रिएट होते. अगर मैं उसे कोई प्रीफिक्स पास कर देती, फॉर इंस्टेंस माय प्रीफिक्स वाज इक्वल टू GEN, तो ये इस तरह से इंकोड कर देता. एवरीथिंग एल्स वुड रिमेन द सेम, but this is what my new columns would look like. So this isn't something that, I mean, carries a lot of weight, just to tell you. So मैंने ये पास किया है. As opposed to marital status, अब ये सिर्फ marital रखेगा prefix को. Drop first equals true. I want to talk about this, but first I want to show you what I have been able to obtain over here. This is what I have obtained. For a second, I'm going to remove this altogether and then show you what I obtained. So अब मेरे पास ये है, exactly what I told you. So हमने prefix को लिया and then her unique value के against रख दिया. True false is just 0 1. Essentially, this is exactly what I was going for. जब मैंने drop first किया तो उसने इनमें से एक को drop कर दिया. So let me go back and show you again. Now the divorced column is gone. Drop first ये करता है कि जो पहली उसके पास unique value आती है उसको drop कर देता है, and बाकी दोनों को it just leaves them in place. Essentially, this is a practice that you follow to avoid the problem of collinearity. I believe collinearity must have been discussed in class as well, and I will quickly though help you recall what collinearity means. Before passing your data to your model, ऐसा नहीं होना चाहिए कि कोई एक फीचर जो है वो बाकी दोनों फीचर्स का लीनियर कॉम्बिनेशन हो. And one hot encoding में by default, this is exactly what happens. One column is a linear combination of the other two. I'll tell you how this works. अगर आपके पास एक certain row आई है जिसमें gender male equals 1, and or rather, let's take an even simpler one where gender male equals 0 and gender other equals 0. So can I predict कि gender female क्या होगा? Obviously it's going to be equal to 1. This is collinearity. One column is a linear combination of the other two. If I know the values of the other two, I can just tell you the value of the third. This is something that we want to avoid when we are passing our data to our model, which is why we drop one of these three columns. So this is essentially what I've done over here. And then, of course, I went ahead and I did the exact same thing for gender. Gender, maybe I had three unique values. Drop first by default, पहली वाली को drop कर देगा. So let me just display this for you as well. This is what has happened. So by chance, female just occurred pehle, which is why it has dropped female. I'm still passing it all the information that I need, though. I'm not getting rid of any information. Just to quickly tell you, because even if you have a row like this, for instance, row number 496, जहाँ पे both of these are false, so still I'm giving the necessary information to my model because this means कि female must be true. Both of these are false. So I'm not hiding any information from it. Anyway, now that I have transformed all of my features, I am just storing them in one final data frame. You will see that I have age over here, I have encoded education, and then I have these one hot encoded values for gender and marital status columns, and purchased is just there exactly the way that it was. This is my final data frame, which is now ready for my model. this is what we started with. इसको आप directly नहीं दे सकते to your model. So anyway, this is what you have been able to obtain. And now in step three, you will split your data into your training and testing data now that this is ready. So this is exactly what I've done over here. मैंने ऊपर ये एक दफा लिख दिया हुआ था already, but then we went through a data preparation procedure, so you wouldn't want to do that beforehand. And after I've prepared my data, I am doing a train test split. Alternatively, in this example, like I told you, to avoid data leakage, you would perhaps want to do the split first, create two data frames, and then उन दोनों data frames को आप use करें to well, before you do the transform and fit transform. Anyway, this is what I've obtained. Then in step four, I am initializing my model. The only difference at this point is कि पहले I had linear regression, now I have logistic regression. Once I define my model, everything else is exactly the same. Well, at least for a bit until we evaluate. So, model dot fit आप use करते हैं. Again, dot fit को x train and y train pass हो रहा है. Then in step 6 you make predictions. So model dot predict, you only pass x test to it, you don't pass y test to it. And then you will evaluate your model. So model dot score आपको accuracy निकाल के देगा. You will realize that we're not computing R square, we're not computing MAE, we're not computing MSE because all of those were used for regression. So this I will quickly walk you through actually, and then you will definitely cover these in a lot more detail in class as well. We're going to use accuracy. My accuracy is 91% right now, and your accuracy is as simple as the number of values correctly predicted divided by the total number of values. You know, मैं purchasing behavior predict कर रही थी. I was predicting a number which would have been 0 and 1, either 0 or 1. So this is just telling me कि कितने instances मैंने ठीक predict कर लिए, whether they were zeros or they were ones, divided by the total length of my testing data set, and that is 91%. Then you have a couple of other metrics over here that you use to evaluate a classifier. Accuracy score हमने देख लिया है. Then you have precision, recall, and F1. I will not delve into what each of these means, but I will tell you how to interpret a confusion matrix though. Confusion matrices help us a lot with classification problems. बेशक एक class हो या आप multiple classes हो आपके पास या multiple values of one class. So this is what my confusion matrix looks like. I've again used a function that was available in sklearn and I've passed y test and y predictions to it. My ground truths of my testing data and my predictions for that testing data. So इसका आपके पास एक better view भी available है, which I'm making using the matplotlib library, and anyway I will show you how to interpret this. आपके पास एक एक्सिस पे ट्रू लेबल्स हैं और एक एक्सिस पे predicted labels हैं. This value of 50, which is labeled here with a true label of not purchased 0 and a predicted label of not purchased 0, 50 represents the number of values जिनके लिए the prediction was 0 मतलब no purchase मतलब negative, and my model correctly predicted them as no purchase. 41 is the number which represents the items, sorry, not the items, the values जिनके against predict the ground truth was purchased. It was one positive, and my model correctly predicted these as positive. So ये आपके पास true negatives हैं 50 and true positives हैं 41. Then I'll tell you what false negatives and false positives are in this scenario. ये जो 5 का नंबर है जिनकी प्रिडिक्टेड वैल्यू 1 है और ट्रू लेबल 0 था, सो आपने इन्हें फॉल्सली प्रिडिक्ट किया एज 1, यू प्रिडिक्टेड देम फॉल्सली एज पॉजिटिव. which is why they're called false positives, and you have five false positives over here. Similarly, 4 is the number of values. Jinki ground label was 1, but you mistakenly predicted them as 0. So these are those that you falsely predicted as negative. These are your false negatives. Um, Lastly, आपके पास एक classification report का function भी available है in sklearn, which tells you the individual performance against each class. It gives you the accuracy. It also tells you the number of examples that it saw of each class in the test set. And then it gives you the macro average and weighted average of these numbers for the classes combined. You will look into these values in more detail, inshallah, in class. Are there any questions up until now? All right, so that will actually be all from my side for today. We will be wrapping up.